So for the warm-up, the directions ask, what two equations would you set up to solve each absolute value equation? So it's not asking you to actually solve anything, it's just asking what you would set up, okay? So here, it equals a positive, so remember, you set 1 equal to the positive, so x plus 2 equals 7, and then x plus 2 equals what? Negative 7, good. All right, b equals a positive, so you would do 3x minus 1 equals 2, and then 3x minus 1 equals what? Negative 2, good. C equals a positive, so you should have x minus 8 equals 14, and x minus 8 equals negative 14. And then D equals a negative, so what's that? No solution. Yep, so you wouldn't even set anything up, you just go straight to no solution. Because that's a negative. All right, yes.
It doesn't make sense because wouldn't it be x plus 2 equals 7, so then you subtract the 2?
Yeah, we're not solving.
Oh.
Yeah, so these it just ask what you would set up in for the directions. Yeah. All right, so your objective today is going to be basically the same as your objective yesterday, just with one word change because we're doing inequalities today. So students will be able to solve inequalities instead of equations involving absolute value. Okay, so we're still operating under the same rules for these where absolute value can't end up equaling a negative, okay? So it has to be either 0 or positive numbers. When we are setting these up, we have a lot of special cases that we're going to go over. But if we don't have a special case where it's like no solution or infinite solutions, and we're going to actually solve it, there's only one change that you need to make, okay? So when you change the sign for the second inequality, you have to also flip the inequality symbol. So what I mean by that is if this was the original, greater than or equal to, for the normal first positive one, it stays the same, but when you do the negative version of the answer, it's going to flip, okay? And then all of your answers are going to end up, besides the special cases, are going to end up as and or inequalities. Remember, the going away ones are going towards each other ones. So the way that you figure out which one of those it's going to be is by just throwing it on a graph and looking at it, and you'll be able to tell what kind it is, okay? Now, we do have a lot of special cases for these. There's 5. So you have to view all of these with the lens of absolute value can't be negative, okay? So here, our first, we have 2 that are going to end up being infinite solutions, and that's going to be greater than or equal to 0, and then greater than or equal to a negative. The reason why those are infinite solutions is because those include every positive number that ever existed plus 0. So bigger than a negative. Isn't every positive number bigger than a negative? Yes? Is 0 bigger than a negative? Yeah, so that one's going to be everything, because everything's going to be bigger than a negative, okay? For this one, greater than or equal to 0, same thing. Positive numbers are all included and 0 is included, okay? For no solution, that's going to be where there are no positive numbers or 0 able to be part of that, okay? So less than a negative, are there any positive numbers that are less than a negative? Is 0 less than a negative? No, so that's why it's no solution, because nothing's going to work there. It's all going to be negative numbers. Less than 0, same thing. Is 0 going to be less than 0? What about any positive numbers? No, those are all going to be negatives. Okay, so anytime it only is going to include negative numbers, it's going to be no solution. Kind of, sort of? Huh? Yes, but absolute value can't be negative. So since this is absolute value, we have to figure out, so infinite solutions is going to happen when you have every positive number and 0 included in that. No solution happens when the only option is negative numbers in that. Okay? And then there's the fifth one is just kind of a weird one. Less than or equal to 0. Because less than 0 are only negative numbers, but there's one shot that you have when it's equal to 0. So that one, we're going to have an equal sign solution, and we're going to do one of every single kind so you guys can see what it's going to look like. But basically what you're going to do is when you have the absolute value by itself, look on the right side and check to see if you have 0 or negative. If you do, then come to this chart and see if it's one of these special cases. If you don't have 0 or negative, we're just going to solve like we normally would. Okay? So we don't have any got-its today. It's basically all, like we are doing one of every possible type of problem you could ever have. Okay, and there's 8 possible types. So we're going to do one of every kind. So let's go to this first one. All right, first thing that you're going to ask yourself on all of these is the absolute value by itself, okay, on whatever side it's on. So here, is the absolute value by itself? Yes. So now what you're going to do is you're going to look at the answer part. If that's negative or a 0, you want to check your chart. So we have a 0 here, so let's check the chart. So we're looking for greater than 0. Just greater than 0. Do we have that one? No. Greater than 0 is not on there, so we're just going to solve it like we normally would. Okay? So we're going to split this into 2. We're going to do x plus 4 is greater than 0. Normally, we'd make the answer negative for the second one. We can't with 0, but we are going to flip the sign. So x plus 4 is less than 0. Normally, you'd also do negative for the second one. Okay, so solve both of those. So how would I solve them both? Yep, minus 4. X is greater than negative 4. X is less than negative 4. So we have x is greater than negative 4, x is less than negative 4. We need to figure out if that's an and or an or. Okay, the easiest way to do that is just put it on the graph and you'll be able to tell. So this one, is it open or closed at negative 4? Open. Going what direction? To the right. This one, open or closed at negative 4? Open, going to the left. So this one is a weird example because it's basically infinite solutions except for one number. So what's the only number that it can't be? Negative 4, right? But technically, are these arrows going away from each other or towards each other? Away, so it's going to be an or, okay? So we're going to do, remember the less than one first. X is less than negative 4, or x is greater than negative 4. So if you don't have no solution or infinite solutions, your answer is going to be an and or an or. Always.
What's the difference between and or?
And is when they go towards each other, like it's between two numbers, or is when they're going away. All right, let's do the next one. All right, so for this next one, is the absolute value by itself? Yes, so look on the right side. Do we have 0 or a negative? Yes, so check your chart. Greater than or equal to 0. And also think about it logically. Greater than or equal to 0, is that going to be all positives or all negatives? All positives, so what do we think the answer is? Infinite solutions, yeah. So it's going to be infinite solutions if this includes all positive numbers and 0, always, okay? And your graph for infinite solutions, remember, is just like including everything, like that. Any questions so far? Okay. Let's go to the next one. All right, is the absolute value by itself? Yes. Do I have a 0 or a negative over here? Nope, so let's just solve it. So split it up. So we're going to do 8n is greater than or equal to 24, and then 8n is less than or equal to negative 24. So make the second one negative and also flip the sign. And then we'll solve that. So how do I solve both of those? Yeah, divide by 8. So we get n is greater than or equal to 3. And then n is less than or equal to negative 3. And then to see if you have an and or an or, just put it on the graph. Okay? So for positive 3, is it open or closed? Closed. Going what direction? Right. And then negative 3, open or closed? Closed. Going which way? Left. Yep, so is that going to be an and or an or? Or, yep, because they're going away from each other. So you're going to just write. Do the smaller one first. So n is less than or equal to negative 3, or n is greater than or equal to 3. Any questions on that? No? Okay. All right, problem 4. Is the absolute value by itself? No. So what do I have to do first?
Divide by 9.
Yep, divide by 9. So absolute value of x minus 1 is greater than negative 5. Okay, is that 0 or a negative? Yes. So it's going to be one of our special cases probably. So think about bigger than a negative. Is that going to be all positives or all negatives? All positives. So what do we think it's going to be? Infinite, yep. So bigger than a negative. That includes all positive numbers and 0. So that means infinite solutions. All right, problem 5 is the absolute value by itself. Yep. Do I have 0 or a negative on that side? Nope, so let's solve it. So you have y minus 2 is less than or equal to 1. Y minus 2 is greater than or equal to negative 1. And then how do I solve both of those? Yep, add 2. So you have y is less than or equal to 3. Y is greater than or equal to 1. And then we're just going to throw both those on the graph and see what it looks like, okay? So at 3, open or closed? Closed. Going what direction? Left. And then at 1, open or closed? Closed. Going what direction? Right. So what do we have? An and, right? So do you remember how to write those? Where does the variable go for an and? In the middle, right? And then what 2 signs do I always use no matter what? Less than, yep. And then your smaller number and your bigger number. And then just put the lines where you would have them. So since they both had a line, we'll have them both have a line. So that's how your answer will look. Any questions? Mm-hmm.
Is there an end to numbers?
No.
Like, I know that there's, like, really high numbers.
Yeah, no,
Well,
we call it infinity.
Yeah, but, like, is it possible to get past infinity?
No.
I guess that is kind of obvious considering the definition of infinity is there is no end to it.
All right, on this one, is the absolute value by itself? Yes. And then, so here for the answer, is that 0 or a negative? Yes. So let's think about it. Less than a negative. Is that all positives or all negatives? All negatives are less than a negative, right? So what do you think it is? No solution. Yep. Good? Almost done? All right, problem 7. Is the absolute value by itself? Yes. We have 0 or a negative, so think about it logically. Less than 0. Is that all positives or all negatives? Less than 0.
Oh.
All negatives are less than 0, right? So what do we think? Yep. All right. Problem 8. Is the absolute value by itself? No. So what do I have to do first? You might say it is 0. Okay, so we have 0 or a negative for our answer. So think about it. Less than or equal to 0. All positives, all negatives? Negatives, except what's included in that that's not a negative? 0. Okay, so this is the weird special case because it's almost no solution except for like that one number that was going to make it 0, and that's allowed. Okay, so what we do on this one is we basically ignore the less than 0 part because that part's going to be no solution, and we just focus on the equal to 0 part. So we're just going to set up an equation. X minus 2 equals 0, just to figure out what the one number is that's going to make it work because it'll be 0. The rest are going to make it negative, so that's not going to work. Okay? So how would I solve that? Yep, plus 2. So x equals 2 is going to be your answer. So x can only be 2. Everything else is going to make it no solution. Okay? So on the graph, you'll just put a single dot at 2. All right, so you have done one of every single kind of problem you could possibly have for these. Okay? 5 of them, 5 of the 8 are special cases. So pretty easy. All right, so I'm going to put up the lesson check. Okay, so go ahead and solve those. I'll put the answers in a minute. So guys, try these. If you haven't yet.
We're not turning in this back in the morning,
No, but you're gonna want it for final exams.
Okay.
So just pick a drawer at home so that you can throw the completed ones in there until the end of the year
Okay.
or the end of the semester. Are you guys ready for answers or not quite yet? Not yet, okay. I'll have you do that.
Wait, when's our next text or test?
It is a 24. Oh right, I needed to make you one for the second half, right? Okay. All right, guys, putting up answers. Any questions on any of those? No, we're good? Okay, then you should have your math Excel out on your computers.